Hello everyone, my name is Satyanarayan, and in this session we are going to take a look at a simple concept in mathematics called divisibility rules. Divisibility rules are essential when you want to check whether a larger number is divisible exactly by a given smaller number or not. So how do we do this without resorting to long division methods? Well, for the basic numbers, here are the rules. We start with 2. Now remember, numbers are either even or odd. Even numbers are those which end with a 0, a 2, a 4, a 6 or an 8. So if the given number happens to be even, that is the last digit is either 0, 2, 4, 6 or 8, then it will be divisible by 2. For example, 216 ends with a 6, so divisible by 2. 3418 ends with an 8, divisible by 2. 24,560 ends with a 0, divisible by 2. On the other hand, 11 ends with a 1, not divisible by 2. 315 ends with a 5, not divisible by 2. And 4,30,46,721 ends with a 1, so not divisible by 2. So remember, if it's even, it is divisible by 2. Now we check whether the number is divisible by 3 or not. Remember, the basic rule here is summation of all the digits. For example, the given number 81. Add the individual digits of this number. So 8 plus 1 is equal to 9. As 9 is divisible by 3, the entire number 81 will be divisible by 3. Or if you want to go in for another, let us check out whether 6,561 is divisible by 3. 6 plus 5 is 11, 11 plus 6 is 17, 17 plus 1 is 18. Again, 1 plus 8 is equal to 9. As 9 is divisible by 3, 6,561 is also divisible by 3. Similarly, if I want to check out, I can ask whether 411 will be divisible by 3. 4 plus 1 is 5, 5 plus 1 is 6. As 6 is divisible by 3, the entire number is divisible by 3. Is 1002 divisible by 3? Well, 1 plus 0 plus 0 plus 2 is 3. And as 3 is divisible by 3, the entire number is divisible by 3. So again, the rule is summation of digits. Keep on adding the digits till you get a single digit number. If that single digit number happens to be a 3, a 6 or a 9, then the entire number will be divisible by 3. Now the divisibility rule for 4 is actually quite simple. Remember, to check whether the number was divisible by 2 or not, we checked just the last digit. Well, in case of 4, we will check the last 2 digits of the number. So for example, 132. Here we just take the last 2 digits, 32, and check. Is 32 divisible by 4? Yes, 32 is divisible by 4, and hence the number 132 will be divisible by 4. In fact, as 32 is divisible by 4, 132 will be divisible by 4, 2132 will be divisible by 4, 52132 will be divisible by 4, 752132 will be divisible by 4. In fact, it does not matter how many numbers we keep adding in front. As long as the last 2 digits are a number which is divisible by 4, the entire number is divisible by 4. So if I want to check, let us say 67,264. I simply check, is 64 divisible by 4? Yes, and hence the entire number is divisible by 4. Now if you want to understand what is the logic behind this, consider this. For 67,264, this is nothing but 67200 plus 64. If I remove the last 2 digits, the entire number is nothing but a multiple of 100 plus 64. And any multiple of 100 is always divisible by 4. So technically, that is why we check only the last 2 digits. So given the example, 21,728, is this divisible by 4? Check the last 2 digits. Is 28 divisible by 4? Yes, and hence the given number is divisible by 4. The divisibility rule for 5 is extremely simple. If the last digit is 0 or 5, then the number is divisible by 5. So 10, 250, 3120, 67,430, or 25, 315, 4,785, 92,165. All these numbers ending either with a 0 or with a 5, and hence all of these are divisible by 5. Now comes the tricky part, understanding the divisibility rule for 6. Now first of all, 6 is not a prime number, and hence we have to first split it into two numbers which are primes. Now remember, when you are asked for the divisibility test of a number which is not prime by itself, try to find out two such factors of the numbers which are co-prime to each other. What do I mean by co-prime? Well, the two factors should be such that their highest common factor is equal to 1. Now, 6 can be written as 6 multiplied by 1, but this is of no real use, because to find the divisibility rule of 6, we cannot be using the divisibility rule of 6. So the second set of factors is 3 and 2. Now we know that the highest common factor for 3 and 2 is 1. So 3 and 2 are mutually co-prime. Individually they may or may not be prime, but because their highest common factor is only 1, they are known as co-prime numbers. Now the rule is simple. The number given has to pass the divisibility rule of 3 and it has to pass the divisibility rule of 2. Remember, it is not optional. It has to pass both these tests individually. So if the number is divisible by 3 and the number is divisible by 2, then the number will be divisible by 6. So let us check. Let us say 36. Now 36 ends with 6 even, and hence it passes the rule for 2. 3 plus 6 is equal to 9, passes the rule for 3. As it is divisible by 2 and 3, this number is definitely divisible by 6. Similarly, if I check out 6,264. Now the number ends in 4, it is divisible by 2. 6 plus 2 is 8, 8 plus 6 is 14, 14 plus 4 is 18. In 18, 1 plus 8 is 9, divisible by 3. So as it is divisible by both 2 and 3, the number is divisible by 6. So remember, whenever we are checking for the divisibility rule of a compound number, we find out the prime factors, two such factors of the number which are co-prime to each other, and apply the individual divisibility rule to the given number and check. Now, the rule for 8. Just as the divisibility rule of 2 was the last one place of the number, for 4, which is 2 square, we check the last two places of the number. Similarly for 8, which is 2 cube, we check the last 3 places of the number. So if the last 3 places form a number which is divisible by 8, then the entire number is divisible by 8, which means you will have to go in for the long division of the last 3 places. So let us say 47,512. Now instead of checking the entire number, we just check, is 512 divisible by 8? Well, 8 6s are 48, 8 4s are 32. Yes, 512 is divisible by 8, and hence the number 47,512 will be divisible by 8. So I repeat, whatever the number is given, let us say 72,408. Check, is 408 the last 3 digits divisible by 8? If yes, then the entire number will be divisible by 8. What is the divisibility rule of 9? Well, 9 happens to be the square of 3. So again, we use the addition or the summation rule here. That is, if the sum of all the digits of the number happens to add up to 9, then the number is divisible by 9. So 81 is 8 plus 1, which is 9, divisible by 9. 729 is 7 plus 2 plus 9, which is 18. 1 plus 8 is 9, so divisible by 9. 6,561 is 6 plus 5 11, 11 plus 6 17, 17 plus 10 18, 1 plus 8 9, divisible by 9. So keep on adding the numbers till you get a single digit. If that single digit happens to be 9, then the entire number is divisible by 9. this has to be the simplest rule. If the number ends with a 0, then and only then it is divisible by 10, which means the number is divisible by both 2 and 5. Remember, if it ends with 0, it is even and hence divisible by 2. If it ends with 0, it is divisible by 5. 10's co-prime factors are 2 and 5 because 2 multiplied by 5 is 10. So the number ending with a 0 will always be divisible by 10. The rule for 11. Well, this is a bit long rule, but it is not that difficult and it does really help to solve the questions pretty quickly. So what we do here is basically we write down the number. Let us say 1, 3, 3, 1. We make groups of all places, all the numbers in the even places and all the numbers in the odd places. So 1 plus 3 is 4, 3 plus 1 is 4. We take the difference of these numbers. If the difference happens to be 0 or a multiple of 11, then the entire number is divisible by 11. To explain this concept further, let me take a rather larger example and see whether this can really work out. So let us try to do this. Let us say the number given is 7, 2, 5, 1 and 2. Chalo. So let us take all the odd place numbers 7, 5 and 2. So 7 plus 5 is 12, 12 plus 2 is 14. The remaining numbers 2 plus 1 is 3. I take the difference. 14 minus 3 is 11. So because the answer is either 0 or a multiple of 11, this entire number is divisible by 11. So if I check 121 as the example, odd place is 1 plus 1, 2, even place 2, 2 minus 2, 0, difference is 0, so it is divisible by 11. Or if I take the example 8, 1, 5, 2 and 1. So again 8 plus 5 gives me 13, 13 plus 1 gives me 14, 1 plus 2 gives me 3. So the difference 14 minus 3, 11, is divisible by 11, so the given number is also divisible by 11. So the difference of the numbers in the odd places and the even place, if it is 0 or a multiple of 11, then the answer happens to be that the given number is divisible by 11. Now 12 being a composite number, we have to go with the co-prime rule. Now 12 can be written as 2 multiplied by 6, but the highest common factor for 2 and 6 is 2, which is not 1, and hence these numbers are not co-primes. Alternatively, 12 can be written as 3 and 4, and the highest common factor for 3 and 4 is 1. So the best way to check whether a number is divisible by 12 or not is first to apply the divisibility rule of 3 and the divisibility rule of 4. If both the rules are satisfied, then and only then the number is divisible by 12. So for example, if I take the number 6264. Now this number for 3, 6 plus 2 adds up to 8, 8 plus 6, 14 plus 4, 18, 18, 1 plus 8, 9, 9 is divisible by 3, and hence 6264 is divisible by 3. 6 plus 2, 8, 8 plus 6, 14 plus 4, 18, 1 plus 8 is 9, 9 is divisible by 3. Last two digits 6 and 4 divisible by 4. So as this passes the test for both 3 and 4, the given number has to be divisible by 12. So in exam, if you are typically asked whether the number is divisible by 33 or 99, don't panic. 33 is simply 3 multiplied by 11. 3 and 11 are co-primes. So if it passes the test of 3 and the test of 11, then it will be divisible by 33. Similarly, 99 is nothing but 9 multiplied by 11. The highest common factor for 9 and 11 is 1. So they are co-primes. So if the number individually passes the test for 9 and the number for 11, then the answer has to be divisible by 99 as well. I hope you understood the basic factorization principles and the rules on how to check whether the large number is divisible by the given small number or not. A lot of practice will help you quickly identify where to apply these principles and shorten the time you take to solve problems of other chapters as well. These were the divisibility rules for certain basic numbers. My name is Satyanarayan. Wish you all the very best. Have a good day.